Hi folks, you've already learned the complete Boolean logic. There's 9 rules that you can cite in formal proofs in our Boolean system. There's intro and elim rules for the 3 Boolean connectives, plus the contradiction symbol and reiteration. You should be able to break out a piece of paper and write down exactly how each one of these rules functions with the correct citations. If you can't do that, then you should pause this video and go back and look at some of the previous videos. In this video, we're going to look at some more advanced topics and try to figure out some of the difficult ways in which Boolean logic can function. One of the things that I think students find perennially confusing is that there are 2 distinct uses for the contradiction symbol. Sometimes you get a contradiction and you don't actually know what to do with it. And the problem is these 2 uses, either you're going to do contradiction elim or you're going to do negation intro, are mutually exclusive. You can't do both of them. You need to either be doing one or the other, and maybe you don't know which one is the right one. Well, this video is hopefully going to dispel all the confusion by looking at exactly what this difference consists in. In order to do that, I'm going to work with a couple of examples. So let's take this proof. Here we have a premise, A or B or C. So we have a disjunction as a premise, and we have 2 more things. We know B can't be true, not B is the case, and not C is the case. And what I want you to do is think about how you would do this in a formal proof over here on the left versus an informal proof over here on the right. Let's start with the informal proof. And to make it easier, I'm going to give you a concrete example. Let's say that we have some guard and we know they're a knight, knave, or random. So that's our premise number 1. A just means they're a knight, B means they're a knave, C means they're a random. So I know premise 2 that they're not a knave, and I know premise 3 they're not a random. If you were going to justify for someone how this argument is valid, what would you say? What would you do in an informal proof? So pause your videos and just formulate what an informal proof of this would look like. Now, since we're talking an informal proof, you should have given me something in English. If you gave me like intro and elim rules, then you're thinking about this all wrong. Informal proofs have to go by explanations in language like English. And there's actually several different ways you could have done it. So there's not one good answer here. There's several good answers. You might have just said the following. Well, look, we know they're a knight, knave, or random from premise 1. So that's restating a premise. But they can't be a knave or a random from the other 2 premises. So they've got to be a knight. It's just that obvious. Maybe this proof is just so obviously valid, you had a hard time saying much else. If your audience can follow you, this would count as a good proof. But there's also something funny about it, which is it doesn't really give me much detail how this inference works because it doesn't use proof by cases and spell out how we're actually reasoning from the disjunction. But that does not mean it's a bad proof. Maybe this is a good enough proof for your audience. That's the difficult thing about understanding informal proofs. There's so much variability. Here's the way you might have done it where you're actually using proof by cases. But this is very similar to the first method, but it's using proof by cases. What you do is you say, case 1, let's assume they're a knight because that's the first disjunct. Well, of course, the conclusion follows in that case because that is the conclusion. So let's go to case 2. Assume they're a knave. Well, we know case 2 is impossible because premise 2 says they're not a knave. So in a sense, we're like crossing out that case. We're ruling that case as an impossibility. Same with case 3. Let's assume they're random. Well, premise 3 makes that impossible. Since these cases can't possibly hold, case 1 has got to be true. They have to be a knight. So this is a way of using reasoning that's very similar to the first version, but it's spelling it out in more detail in this way. Now, there's still a third way you might have done it. And this way is actually the way that gives us a sense of how this would go in the formal proof case, the formal proof setting. So here again, we're going to use proof by cases because our premise is a disjunction. And case 1 is the same. We know they're a knight, so that's the conclusion. Case 2, let's assume they're a knave. Now let's use premise number 2 to form a contradiction. Premise 2 and this assumption are a contradiction. Since that entails anything, we know our conclusion follows in that case, namely that they have to be a knight. Case 3, I don't even spell it out. This is quite common practice in more advanced proof writing, where if one of my other cases is identical, is sort of the same structure as a previous case, we just say, oh yeah, this is just like the previous case, and we assume the audience can fill in the details. This happens all the time in logic and mathematics journals. And so what we're doing is we're spelling it out with proof by cases, but we're using the contradiction method in order to show that the conclusion really does follow in any case, and we're using that funny fact that a contradiction entails anything. Any of these 3 would have been good informal proofs. So if you used any of these, you would get full credit. Now what I want to do is look at how the formal proof setting would work. Now that we're in this formal proof space, we're only allowed to use intro and elim rules. We have to justify everything carefully. Now, the structure is still going to be similar. Since this is a wide scope disjunction, we need subproofs for each case. And again, subproofs work by making temporary assumptions. That's why I wrote assume over here. And because this is a three-way disjunction with all disjuncts having the same scoping, the number of disjuncts tells me the number of cases I need. That's why I've got 3 cases here. Now, how do I fill in the rest of the details? When we're in the formal proof space, we have to do it the way that we did third in the informal case, where we actually use the contradiction. Because the formal proof case does not allow us to say, okay, well, B, this has to be impossible because of premise 2. Here we have to actually introduce the contradiction symbol and then use contradiction elim to actually prove the exact same sentence follows in each case. Because disjunction elim does not have that flexibility of the informal proofs, where if my audience can follow me, then I'm good. I have to actually derive the exact same sentence at the end of each one. So this is what it would look like in the formal proof space, where my disjunction elim cites first the disjunction I'm eliminating on line 1, and then it cites my 3 cases. That's why I have 3 separate things here. There's also something additionally funny, because case 1 actually is my conclusion. So I did it the fast way, and I didn't even repeat my sentence A. I could have used reiteration to add another line. So if you did that, that's totally great. But since A is, technically speaking, the rule disjunction elim says each case must end with my sentence, my conclusion that I'm exporting. And technically speaking, this subproof does end with A. It begins and ends with A because it's only one line. And in that case, you're allowed to just cite that individual 4, because that is citing the whole subproof. No dash is needed if there's not multiple lines of the subproof. So this actually counts as a perfectly fine way to do it. If you wrote 4-4, that's perfectly fine too. That would also get full credit. That's an adequate way to do it. Now, we've said previously that even all of these bars are not necessary. All we need is some way of specifying when something is in a subproof. So if we would have done it in the more austere way, using this vertical bar for subproofs, it would have looked like this. What's sometimes confusing about these is when you have all these extra lines, it really tells you clearly where one subproof ends and the next one begins. And that information is potentially lost here. You can't just look at these lines to tell where they end and begin, because each line is sort of self-standing. But look at the assume lines. See, if this one says assume, and then I have a different assume, this has to be a new subproof. So this one must have ended there. That's a one-line subproof. And this subproof goes just as far until either I jump out of the subproof or I write assume again. So this is again starting a new subproof. That subproof ended here. And finally, I know this is the end of my 3rd subproof, because here I've jumped out of the bar segmenting the subproofs and I've gotten to my main conclusion. So the proof would look pretty much identical. All these lines really are the same. All these justifications are the same. It's just a little harder sometimes to read where the subproofs begin and end without all of these visual clues. That's why I like including these bars, especially when teaching this information. All right, now, if you understood all of that, what I want you to think about is this next proof. So this is the little game. You have to figure out what's problematic about this proof. So pause your videos here and see if you can identify the problem. Okay, that was your chance to pause your videos. Of course, the problem is down here, contradiction elim. You see, this is like the previous cases where I did contradiction elim, but look, I did contradiction elim and I jumped out of this scope line. That you're not allowed to do. When I was doing contradiction elim in the previous example, like look at contradiction elim on line 7 or on line 10, I didn't get to jump out of the scope line. I needed disjunction elim to get me out of the scoping. So the thing about contradiction elim, this is one of the 2 uses of the contradiction symbol, is it always keeps you within the same scoping that you're on. If you're in a subproof, it keeps you in a subproof. And that's why this is totally disallowed. I could use the contradiction elim rule validly if I wanted, but it would look like this. It would be stuck inside this subproof still. This would check out. This is not invalid. But the trouble is, when I'm proving not B, my conclusion here, from B, it does me no good to get not B inside the subproof, because what I'm doing is I'm doing a reductio. And if I'm doing the rule for reductio, negation intro, I have to end the subproof with a contradiction symbol. I can't end it with some other sentence like my conclusion. So when you're doing proof by cases, you actually get your conclusion here and you export it. But when you're doing reductio, you stop at the contradiction symbol. And then you don't export this thing. You move, you add a negation to this. And that's how I get not be. So the ultimate idea is to remember why you started the subproof. That tells you how you need to end it. And that tells you whether to stop at the contradiction symbol or whether you should continue on and eliminate the contradiction symbol. Since this was proof by cases, remember, so here's our previous example. Since this was proof by cases, I can't export the contradiction symbol because case number 1 is not contradictory. That is my conclusion. What I need to do is I need to export A. So that's what told me contradiction intro was just the first step, and I needed to derive A. That was my mechanism for getting A. That was one use, that was one plan for the contradiction symbol. I got it here because I wanted to use it to get my sentence A with contradiction E then. The other plan, if I'm doing reductio, if this is my plan, then I need to end with a contradiction symbol. Don't eliminate it. So the ultimate lesson is this. If you're asking yourself, do I use contradiction idem or do I use negation intro? The question to ask is why, what do I want my subproof to end like? Should it end with my sentence that I'm exporting, or should it end with a contradiction symbol? If you don't know how it should end, then you just have to ask yourself the previous question. Why the heck did I start the subproof in the first place? Because that tells you how it ends. If you started the subproof because you know a disjunction, you're going to export something out. You're not doing reductio. Now, if you started the subproof because you negated your conclusion, then you are doing a reductio. So knowing why you started the subproof tells you how it should end. And then that will tell you whether your goal was negation intro or whether you might be using the contradiction symbol in the middle of it for contradiction intro. Now, of course, if you ask yourself, why did I start it, and you don't know the answer, then that's a whole different problem. You should never start a subproof if you don't know why. There's 2 reasons, and only 2 reasons at this point, to start a subproof. One is because you know a disjunction, and the other is because you're negating your conclusion. If neither one of those is your reason, then you should not have started the subproof in the first place. Okay, so this video has tried to dispel some confusion around the contradiction symbol. The main lesson is there are 2 very different reasons why you might be using the contradiction symbol. One is to actually eliminate it, and the other is for reductio. And you can clarify your goals. You can understand, get rid of some of this confusion if you can know what is your plan, what is your goal for using it. Are you doing a reductio or are you not? Okay, thanks.